first standard deviation to the left here?
13.5.
Perfect. And then keep going.
11.
And?
8.5.
Good. So now it's just asking, 68% of our data is between what 2 hours? Well, that's the second one. But what was our mean again for the first blank here? What was the mean? Good, so put 16 here. Sorry, the blanks are a little funky looking. So I put 16 here. Then it says, between what 2 numbers is 68%? Think of your empirical rule.
13.5.
Good. So between the first deviations here is 68% of my data. So I'm going to put 13.5 and 18.5. Again, I'm just going to highlight for you because we're talking about this little piece in green. And our empirical rule says that that's 68%. So that's why we're labeling it that. Now what about 95%? Between what 2 numbers?
11.
Good. And again, because the empirical rule says that if you have 2 standard deviations over, like in yellow here, that's going to get you that 95. Now what about the 99.7? Good. 23. 8.5 and 23.5. Good, good, good. Okay. It seems like you guys are getting in that, and that makes me very, 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 very happy. Okay. All right. Do you have questions on that part at all? Because that was basically summing up what we did yesterday. Okay. I'm going to read the bottom while people are still copying down. Problem 1, the fuel efficiency of a sample of hybrid cars. So we all know that there's hybrid cars out there. And what are hybrid cars? Does anyone know my car people? They're what? Oh, okay. But like, what does hybrid mean? I don't even know.
It's like battery.
Oh, battery. So you don't really use gas. Okay, so thank you for clarifying that. My autos people needed. I thought Alex was in here waiting for him. Anyway, so with a mean of 54 miles per gallon. So that's pretty high, okay? 54 miles per gallon, that's really good. That's why they're hybrid cars, okay? Like my car does not get 54. I feel like it's 29 or 32 or something miles per gallon. So this is really high for hybrid cars. And a standard deviation of 6 miles per gallon. Okay, so I'm just going to write that out so I know that my mean is 54 miles per gallon and my deviation is 6 miles per gallon. Right? So use the mean and deviation to label the intervals. That's what we just did for the warm-up. So what number is going to go in the middle? Okay, good. Now take a minute with yourselves or a group member and fill in the remainder of these tick marks. I really need you to get used to doing that. So remember, you just take that deviation. I'll do the first one with you. And you add 6. And what do you get? Good. So fill in the rest, please. And you can check your answers in a second. Hopefully I did my mental math correctly. I don't know. Did I? No, I didn't, did I?
No, it's 72.
My mental math skills. I need to start doing extra math again.
48, 42, 36.
I need to start doing mental math with you guys. Okay, or extra math with you guys. Any questions on that part? You were just adding or you were subtracting 6, depending on which direction you were going. Okay, so we're done with part A. Then it says determine the percent of hybrid cars that get less than 60 miles per gallon. So I'm going to find 60. Here it is in yellow. Put a tick mark there. Okay, and I want less than. So am I going to move to the left or am I going to move to the right? To the left. Good. So I'm going to shade that in. Okay, so I want less than that. Someone just give me some strategies on how I'm going to figure this out. Good question. So it says determine the amount of cars that are less than 60. So we're going to find 60 and put like a little tick mark. And because we want less than, we know we got to go this way. Good question. So, can anyone shoot out ideas? Because there are so many ways you can do this. I want to kind of hear your thoughts. Oh, what are you going to subtract?
34 minus 13.5 minus 2.35 minus 12.
Are you going to subtract them or add them? Add them. So you want all of that. So that was a good idea. So I have 34 here. I have 34 here. I have 13.5 here. I have 2.35. Is that next? Then I have 0.15
Where are you getting those numbers?
from our empirical rule on the green sheet. Yeah, you might like the bright green sheet, your vocab sheet. Remember we were using that? Okay, so we want less than that. So when you add all of them, what do you get? So you get 84% because we added them. There's another way. Did anyone else think of another way to do this? Because there is. Well, I'm going to show you, maybe this might be easier to see now. In my purple highlighter here, if we have a whole percent and this whole half of a graph, what do I have? In purple. 50. And then what's this little itty bitty piece right here? This guy.
Oh, sorry.
This guy. We already wrote it earlier. 34. When you add those two together, you get 84. So just depending on what your mind is thinking, like half of my graph is 50. And I know this piece is 34 to get 84. Or you could just add them all up. 0.15 plus 2.35 plus 13 plus 34 plus 34. Totally up to you. It just depends on how your brain works. Someone in 7th hour takes the whole thing and subtracts the piece. Again, totally up to you. As long as you get the right answer as me, I'm very, very happy. Okay, then it says determine the percent of hybrid cars that get less than, so we have less than 66 miles per gallon. So we already know this whole piece, don't we? This is all 84. But what if I add on this green piece? What am I adding on to 84?
Isn't it like 13.5?
Good. So I'm going to take that 84 and add 13.5, and what do you get?
97.5.
There you go. Again, these are all coming from your empirical rule, which is on your vocab sheet. So make sure you have that vocab sheet. Or again, if you like totally just didn't even read the question right, you could have just added all of those up from your empirical rule, and that would have been fine. There are so many ways you can do this. I know somebody, like I said, in 7th hour, what he did is he took 100, because the whole graph is 100. And in blue, he subtracted these pieces. It just depends on how your mind works. So he did 100 minus 2.35 minus 0.15, and if you notice, you're going to get the same answer as me. So it's totally up to you. Can someone verify that? 100 minus 2.35 minus 0.15, what do you get?
97.5.
There we go. So it really just depends on how your brain works, and I will accept any answer. As long as it's any way that you do it, I'll accept it as long as you're getting the same thing as me. So that's all from yesterday. So if you weren't here, hopefully that kind of gave you a little taste of what we did yesterday. So when you're done, just flip your answers. You're going to need that dark green sheet that you picked up in a little bit.
You look at one.
Yes. I'll give you a second to breathe. I need to get that sheet up myself so that I can show you how to use it. There are times that you are not always given a problem where the deviation isn't there. And that's what I'm going to explain to you in a second here once I get this up and going to show you. One note. And I just want print. Hold on, it's freezing on me. Okay, cool. All right, so we're back to these notes. So let's flip the page and look at what it says. I'm in the wrong one. was it? Oh, there we go. Okay. So it says here, when data values are aligned with integer multiples, which is basically what we did for the warm-up, where we just kind of lined them all up where the deviations are. You can use the empirical rule. So that's what we learned yesterday. But what if the data values are not within the standard deviation? Okay, so this is going to be a little bit different, but I think you're actually going to find it. How are you guys with like reading a table, like which we have in front of you, the green one? Because you're going to have to read some tables on the SAT, so I'm kind of glad to bring this in now. All right, so let's consider, we're going to do a lot together. Let's consider the fuel efficiency of hybrid cars again. The mean is 54, like we said, and one standard deviation is 6 miles per gallon. We already made this chart. This is what we did in the first page. They just rewrote it for us. What percent of cars gets less than 57? Well, let's look at this. This 57 was not originally on our normal distribution from the previous page. So we're going to have to do a little more work to find what's under the curve. So if you have the empirical rule, it's going to be super easy. But if you don't, we're going to have to do a little bit of work, and I'm going to show you how to do that. Okay? So I want to go down to the formula right away. So go to B, please. It says the number that you calculated is called the z-score. So we're going to start doing the z-score, and I want you to highlight if you have a highlighter. If not, then you can just underline it. A z-score is a specific data value and its distance from the mean in terms of the standard deviation. Now again, that's just a vocab term. It's all new to you, and you'll see what it means in a second. So have your vocab green sheet out. We're going to fill that in on our vocab sheet. This way that you can use this on the test, and you'll be able to answer these questions. So the z-score, a number that describes a specific data value distance from the blank. The mean, very good. So if you ever get asked to find the z-score and you don't know what it is, please get out your green sheet, and there you go. And that's for the z-score. Okay.
Can you go up to standard or normal distribution?
Oh, we didn't fill those in? Sorry, guys. Go ahead and fill those in, too. 68, 95, and 99.7. That's what we talked about yesterday. Oh, there's no water. And you said that you guys didn't have the other one either? Right here?
It's just that one.
So if we didn't get standard normal distribution, we put mean here. We put the mean, yeah. So the mean is very important when you're doing any kind of statistics. The average of something, that is very, very important. Pretty much every problem, yes. Okay, I'll keep that up for a second. I'll keep that up for a minute here, because we have some time. Okay, so let's go back to the notes. We are on 1.2. No, 1.3. There you go. And let's talk about what these mean. We know a few of these. What does this U mean, this mu symbol right here? The mean. Good, so I'm just put that in there. What does this sigma symbol mean?
Standard.
Good, the standard deviation. These other two we haven't really talked about, but can you just guess? Yes, Z is the z-score. X is just going to be your data value. So what in the previous problem, we were looking for a hybrid car with 57. That 57 would be your data because you're looking for 57. Okay? Any questions? This is just your formula, so this is super important. You're going to be given it, and it's on your green sheet. If you look at your vocab sheet, that's on there. So you have that formula always given to you. Because on the exam, You know, that's going to be very, very crucial, that bright green sheet, so make sure you are filling that in as we go. All right, so it says, find the z-score of the following data value using the normal curve that we already been using. So we're not going to do any other crazy work here. So this, if you're looking for 70 miles per gallon, it's going to be your x. Like, that's the value we're looking for. What was the mean of our original problem all the way on the top? What was our mean? 54. So let's just write that out so we remember. What was our deviation? It was 6. Very good. So look, we're just going to plug in the formula. You're going to see it's very, very easy. We're just plugging it in. Use your calculators. It's going to be super simple. Okay? So if you look at your formula right here, we're just plugging it in. So we don't know z. We're looking for it. So z equals x, which is what? 70. Minus our mean, which is what? Good. All over 6. That's pretty easy. Put that in your calculator, but if you're putting it in your calculator in red, you need to use parentheses. All right, so go ahead and do that and let me know what you get. 2.6 what? Good. So you have 2.66, and we're going to round it to 7. You always, always, always need to have 2 decimal spots when you're doing z-scores. So I'm going to put a star here. You always round. Your stomach hurts? Do you need to use the washroom? Always round to 2 decimal spots, just decimal places. That's important. You need to have 2. I know we're so used to just being like, okay, it's 3. For the z-score alone, just for statistics, you're going to have to round to that 2 decimal spot right here. And you'll see why in a second. But that's our answer. I want you to give the next one a try. First I'll help you. What does 53 represent? What letter? X. Because it's the value you're looking for. I want to know 53 miles per gallon. So you plug it into your formula. We don't know z. Give it a try and give you another minute here.
Is there standard deviation always 6?
In this problem, yes. Until we change problems, right now it's the same mean and the same standard deviation. Good question. Good. Okay, so where are we going to put first here in our formula? Good. And then? All over? And you are left with what in the calculator? And when you round, it's 0.17. Good. So make sure you're rounding. It won't be a huge deal, but if you don't round, you're going to get a different answer. Yes? You need to have only 2 spots. Yes, so right here, always round to 2 decimal places. The reason why you're going to see in about a minute and 30 seconds why we can't do 3, because it's not available in our chart that we're about to use. If you would have put 1.6, you're going to be really close to the same answer as us, but it will be a little off, and you're going to have to recognize it on the exam. Like, you're going to be a little bit off the multiple choice. Will gum help you? Will gum help you? Okay. Yeah. No, I'm just trying to be nice. I don't have many pieces left, but flip when you're ready to go. Okay. Now I'm giving you all the information. Take a minute, and I just want you to do the first one, then we're going to move on. It's the same thing. Same exact problem that you just did. But now I'm giving you different stuff. I'm giving you x, I'm giving you the mean, and I'm giving you the deviation. So plug it into the formula. You got this. The more you write the formula, the more it'll stick in your brain. And if you want to throw in parentheses in the top just to help you remember, do that. I just want you to do this first one. Give it a try and see how you do. Good. Everyone keep going with that. Maybe a second.
What is M?
This little mu, that's the mean. And then this is the deviation. And this is the formula. And that formula is on your chart if you need it. All right, let's see if you got the same thing as me. And that is your z-score. Okay, that's what you're looking for. You got negative? Did you switch it on me?
No.
How did you get negative? Oh my god, it is negative. Thank you. Thank you. Yep, it is negative. You're right. Good, good, good. Awesome. So that's not that hard. That's really all you're doing for a little bit. Okay? But now we're going to go on to the chart in a second here. So now let's go back to that original problem that we were asked a little bit ago on the previous page. Okay? We're not going to evaluate Greg's work at all. We're just going to look and see if we can find the percent. Let's see if I don't even want to do any of that. Okay, I do. So here's our curve. I want to find my z-score. I am looking for 57 miles per gallon. 57 miles per gallon. That's my x. Find your z-score. So I have z equals what number on top if I'm looking for x? Good. Wait, what'd you say?
57.
What's the value of x? I kind of just told you. 54. What is our mean? 57. Oh my goodness, guys. I have it flopped. 57 minus our mean of 54 all over our deviation of 6. So this is from the same problem from the last page where our mean was 54 and our deviation was 6. You got, what'd you get? Good. So you got 0.5. Now, there's not two spots there, is there, after the decimal place? So I'm just going to put a 0. If there's no spot there, and I'm going to show you why in a second, because if you don't, you might get confused in the chart. Now we can actually find the percent. So you know on the empirical rule we were finding percents, like what is the percent of hybrid cars that actually are in that range? We're doing the same thing now, and there's a way to do it with that awesome chart that I would never have you memorize unless you really want to. I challenge you to do it because I would never be able to. I kind of took a little snippet of it. So on your notes, look at the chart because it's kind of like how yours is on your green chart. You're going to look, I'm going to highlight here, for 0.5. If you look here, you have 0.5, 0. What is this as a percent right here? See if you can convert that for me. 0.6915. What is that as a percent?
0.70.
Yeah, if you were to round it, it would be 70. Yes. So we're going to say then there are 69.15%. So like we did in the empirical rule, we found the percent of data. Well, 69.15% of hybrid cars get less than 57 miles per gallon. Okay? So this is how we're still doing that empirical rule, but now we're putting it one step further. And we're going to do some more problems together. We're going to just keep flipping. We don't need to do that, but let's do this next one. Ready? We're not going to get through all this because I don't want to do the calculator because that's too confusing. I'd rather you just use the chart. But I want you to go right here. 70 miles per gallon. That's our x. So let's find our z-score. So I'm going to put a little star here. Always find z-score first. You can't do these problems unless you have your z-score. So here we go. The more you, I'm telling you, this is going to become like second nature to you. What's my x that I'm looking for? 70. And then we're back to the same problem. We're still on the same, yeah, minus 54 all over. Good, because we're still on that same exact problem with the hybrid cars. So I'm even going to put that on the side so that you know the mean is 54 and the deviation is still 6. We're still on hybrid cars here. You got, let me just double check. You got what? 2.67. Did anyone not get 2.67? That would like. Do you need to round it?
It's already rounded.
It's already rounded. Perfect.
That's like 2.6.
Is it 2.66? Awesome. Okay. Here we go. Get out that green sheet, and you really need to do this with me because otherwise the dark one that you picked up with a big table, because this is going to be your sheet. I want to make sure that you understand how to do this, so you really, really need to focus right now so that you can understand it once. I feel like once I show you one time, you're going to be just fine. Try to zoom out so you can see the whole table here. If you notice, one side of your graph has negatives and one side of your graph has positives. So what are we going to be on? What side? Positives, because we got the answer of 0.67, right? Was it 2.67? Yes. So you first want to start on your left, and if you want to write that first, you always do your left side, then you do your top. You can write that right on your green sheet if you need to. So the first two numbers, 2 point what? What was it? 2.67. So go down your table and find 2.6. So we're going to go scroll down here, scrolling down. Here it is, 2.6. What was our next number? 7. So if you look on the top, you're going to see a 7. So 1, 2, 3, 4, 5, 6, 7 right here. And you got to like read the table. I'm trying to do it like 1, 2, 3.
0.9962.
Yeah. Okay, so you put your finger on the side, 2.6. Let me zoom out so you can see what I'm doing here. So here's 2.6 right here in red, and here is 0.7. You put your fingers, and you just find it. It's hard with the reflection. Down and down. What do you get?
0.9962.
Good, 0.9962. What is that as a percent? Good, 99.62. It'll become second nature to you, I promise. You just got to give it some time. Hold on, something just happened. Good. So, equals 99.67%. Let's do it again so that we are getting used to it. And I hate that my clock is still gone. Let's find our z-score first. Try to zoom in again. Zoom in. Okay. I have right here.
3 minus 54 all over 6.
Good. So then that gets me negative 0.1. Does it round?
Well, there's already a 1.6.
1.6 what?
1.666.
So 1.66. So think about this for a second. Let's do a lesson in rounding. 6. Is this guy, because we got a round here, is that going to round up? Yeah, so it's 0.17. If you did not round, it's not the end of the world. I would not dock you for that. But you want to get in the, you want to be as accurate as possible when you're doing statistics. So you want to round. Question?
Yeah, but as far as the other column, you know how like we did with the chart, how did we go from like 0.07? The 7 was the rounded number.
Yes. So let me explain it. And can I do this one so I can show you?
Okay.
Yeah. So when I say that you do the left side first, you're talking about this in yellow. The top is the 7. So if you go to your chart, let's go to your chart. Go to your negative side. Make sure you're on negative. So I have to flip the paper here to negative. I want 0.1, right? 0.1. So I'm going to find it on the left side. Here it is in yellow. That's 0.1. Go all the way down until you find it. Then on the top here, you finish it off. I need to find a 7. Here it is. What I do is I put my fingers on those two, and you go down or to the right to where it meets. So, good. I'm going to do it with you though. Here in green is where your fingers should meet. So let me explain that. So again, your answer, your z-score, was negative 0.17. So I'm going to go down and I get negative 0.1. Then I go to the top and finish it off with the 0.7. Then I just go ahead and I try to see where it meets, and that's what gets me the 43.25. Do you have questions on that? Okay. So, what percent of hybrid cars? I don't know why it keeps doing that. What just happened? My notes just disappeared. I'm just have to use this. So, what percent of cars have less than 53 miles per gallon? Good, 43.25. My other notes disappeared on me for some reason. You had work over here. We're going to have more practice with it, so don't worry. Okay? I'm not going to show you the calculator because it's actually a lot easier just to look at your chart than it is to put in the calculator. Okay? And that's all I want to really do with you. What time is it? Let's do one more. This next page. It says calculate each percent using the z-score table. That's what your homework's going to say tonight. So zoom in. I'm going to zoom in here. So what's cool is that it says the battery life of a laptop has a mean of 16 hours and a standard deviation of 2.5 hours. That applies to this whole entire page. And that's going to happen to you on some of the problems we do, where I just give you one mean and one deviation, and then you have to do some work on it. So is the z-score associated with 17 hours positive or negative? Okay, so kind of think about this for a second. I want to show you a trick that would kind of help you out on something like the SAT. You don't have to draw this in unless you want to. The mean is 16, right? If I'm looking for 17, is that going to be a positive or a negative number? Positive. Here's why. Because look, when you go to the right, it's 17. That's positive deviation. That's positive. So it's going to be positive. And it's because, put the BC, 17 is above the mean. So it's a good way for you to kind of like check your answers. You should, if you do the calculations and you get a negative number, you should know it's wrong because 17 is bigger than 16. Yes?
So if the number is not above the mean, then it's going to be negative?
Yes. So if I would have said, okay, what about 15? You'd be like, yeah, it is negative. Okay, so you look at your mean data, the mean of your data, and if it's bigger than it, so number 2, yes, would be negative. So I just gave you that. Because 15 is smaller than the mean, so it's going to be negative. Because 15 is below the mean. Good. I'm glad you guys are getting that. Okay. I'm going to save between two numbers for tomorrow because I don't want to overwhelm you with stuff. So we will come back to the rest of this page. I want to give you your homework. Okay. It was really hot this morning, and then it became really